Welcome to Calculus 1. In this video, we're going to talk about slopes of a line. Alright, what is so-called a slope of a linear function or straight line is referring to a non-vertical line. It's measure the number of units the line rises or falls vertically for each unit of a horizontal change from left to the right. You may probably remember this. When we draw a straight line, we can actually find the slopes of a line. So if I have an x and y axis, and here is my linear function, a straight line. If I would pick 2 points, pick any 2 points on the line, and the 2 points has a certain x and y value. So let's say this is my first point, x1, y1, and this is my second point, x2, y2. Okay, so the slope is measuring for the rises. So go from the rises from the first point to the second point, it will rises so much. And the way we figure out the rise, okay, the way we figure out the rise is simply by subtracting, okay, the two y values. So the change of y value compared to the change of the x value. So to find the change of your y value, your delta y will be subtracting the two y values. So I'm going to take the second y value, subtract the first one. Okay, compare that to the change of the x value, or sometimes I use the word displacement as well. The delta x, delta is the word change. The change of the x will be taking the second x value, subtract off the first x value. Okay. Now a lot of times we're referring to the slope of a line as rise over run. The line, every point consistently rise the same, runs the same. We'll kind of get away from the rise over run. We begin to use the wording changing y over changing x. Alright, so the slope, we're using the lowercase m of a non-vertical line passing through any given 2 points is always subtract the two y values over subtract the two x value, where the two x value cannot be the same. Because if the two x values are the same, that become a vertical line. So real quick, let's see if we can do some example here. So if I want to find the slope of a line that will pass through these 2 points, okay, by using the formula, I'm gonna just say this first point I listed as x1, y1, the second point as x2, y2. So the slope formula M says take your y2 7 minus the y1 5. What that means is to go from 5 to 7, you're actually going up 2. That's why when we subtract, we get a 2 over, okay, the change of your x. All right, take negative 2 minus 2, and that will actually give me negative 4. So as a matter of fact, this line is actually going down the hill because my slope is actually a negative. Negative slope means the line is going down the hill from left to the right. Positive slope means the line is going from right and up. Okay, going down from left to right, going up from left to right. Okay, so this one is a negative slope. Changing altitude over changing the displacement, the left and right direction. Alright, let's try this example. This example is a little bit tricky because what you notice here is the two x values are the same. So if you really think about it and plot these 2 points, to the right 4 and down 3, to the right 4, up 7, if you connect the 2 points, it's actually going to be a vertical line. If you really think about it in terms of plotting these 2 points on the graph. But if I just take the y27 minus the y1, which is subtracting a -3, over x2 minus x1, which is another 4, this will actually give me 10 over 0. So any number divided by 0 is actually equal to undefined. So a vertical line actually has undefined slope. Okay, so your slope is actually undefined. It's not 0. It's not that you don't have a slope. We actually use the word undefined. So for a vertical line, your slope is undefined. For a horizontal line, okay, where the y value will be the same rather than the x are the same. The y values are the same, give you a horizontal line. And horizontal line, slope is actually 0. Alright, so just a quick review on the slope of a line. Thank you for